All right. Unit 5, Lesson 6, remainder and factor theorems. Let's jump right in. So what is the remainder theorem? Well, we could sit and write out, that the remainder theorem, if we have polynomial, blah-de-blah-de-blah, bloopity-bloopity-bloop, this happens and that happens and the other thing happens. But it's going to be easier to just show you with an example what it means. So in the most practical, simple, straightforwardest terms, for our purposes for this class, the remainder theorem says if we're trying to do this, so if we're trying to substitute and do a substitution and find f of 4 where this is f of x, then we can use synthetic division to figure out what the solution is. So previous to this lesson, what we've done is we've taken this and we've plugged it into each one of these and then we've simplified on out. Well, what the remainder theorem says is that what we can actually also do, another way to solve this, is we can use synthetic division. So we're going to divide. Now you notice I didn't change the sign here like we do if it was, say, x minus 4 divided into this polynomial, right? So it's just what we're substituting, and then we're going to do synthetic division just like we've done before. So we're going to write down all the coefficients, right? So we've got 3 and negative 2. There's not an x squared term, right? And so remember, we have to put in a placeholder 0 there. We're going to put in a 5 for the x term and then a 2. So we're just going to do synthetic division, and this is going to give us the same thing as if we plugged in 4 in here and in here and in here and just did the algebra there. It's going to give us the same answer, right? And that's what we're doing here. We're just doing this a different way. The math is a little bit easier. It can be an easier way to do step by step if you're doing it and you're programming in a computer or whatever else. So just like we've always done synthetic division, we're going to start by bringing down this 3. The 3 goes right there, and then we're going to multiply. 4 times 3 is 12, and then we're going to add here. Negative 2 plus 12 is 10. 4 times 10 is 40. 0 plus 40 is 40. And 4 times 40 is 160. 5 plus 160 is 165. Now that we may want our calculator for. Let's pull that up to double check what we're doing. So let's do 4 times 165. Enter 660. And then we add 660 plus 2 is 662. So our answer is, and you can check on your own time if you want, just plugging in 4 to each one of these things, and you'll get the same answer. You'll get 662 if you do it that way. And that's, for our purposes at least, all the remainders theorem says, that if we're doing this, we can use synthetic substitution and just do synthetic division here. So instead of trying to plug it in and remember to do the steps in the right order and all those things, we just do this simple process. It's a great way to cut down our margin for error at the very least, if nothing else. And there are other reasons why it's useful as well, but that at least is a good way to do it. So the factor theorem is the other thing we're going to talk about. So factor theorem, this one, we are going to write out in words. So the binomial, which I don't think is spelled that way. It is not, in fact, spelled that way. The binomial. About binomial. The binomial x minus r is a factor of the polynomial p of x if and only if we substitute find p of r equals 0. So if it doesn't have so if we do this and it doesn't have a remainder, let's look at an example, put some meat on it, make it clear. So we want to determine whether x minus 5 is a factor of this, and then find the remaining factors. So let's do that. So in order to find out whether it's a factor of this, we're going to use synthetic substitution just like we did just now and see whether we get a remainder that is 0 or not 0, right? So we're going to use negative 5. Notice we didn't change the sign. We're doing synthetic substitution, not synthetic division. Actually, hold on time. We are doing synthetic division, right? So since we're doing synthetic division and we've got x minus 5, we do have to change that thing. So two separate things here. If we're doing synthetic substitution, we don't change the sign. If we're doing division, synthetic division, we do have to change the sign. That's very important that we keep that separate and we do that correctly. And you notice, and that matches with what we saw on the theorem here, right? Because P of R, not P of negative R, right? So it's the opposite of whatever this thing is, right? And so that's why it flips there as well. Okay, so we're going to write down the coefficients. We've got a 1 in front of the x cubed, negative 7 in front of the x squared. We've got a 7 in front of the x, and then a 15 in front of the not an x, right? The x to the 0. Bring down the 1. We've got a 1. 1 times 5 is 5. Negative 7 plus 5 is negative 2. 5 times negative 2 is negative 10. 10 plus negative, 7 plus negative 10 is negative 3. 5 times negative 3 is negative 15. So, and we get the 0, so we get a remainder of 0. So that tells us that this is a factor of this. So what that means is that we can rewrite this as x minus 5, that one factor, times the reduced, that's not the word, give me a second. Yeah, not reduced. Sorry, it's kind of late when I'm recording this thing, and I've been sick the last few days, so my brain is breaking some. The depressed polynomial, this guy, so sad, so depressed, right, would be x squared minus 2x minus 3. Right, so we can rewrite this one as this factor times the depressed polynomial. And remember, to get this, in order to know what kind of x it is here, it's one less degree than this. So it was x cubed, and this one, so it's going to be one less than that, which is x squared. And then we just go descending order from there. So then it says, then find the remaining factors. So we need to see, and we can assume that this is going to factor. If it doesn't factor, then these are the factors, this and that, right? But let's figure that this probably does factor. So let's try factoring this guy. So we can factor this into x and x in the first slot, because x times x is x squared. There's only one option, so it either works or doesn't, right? Because 3 only has the factors 3 and 1. So let's do our smiley face and see whether this works. 3 times 1 is 3, and 1 times 1 is 1. Can we add or subtract those to get negative 2? We can if we do a negative 3 and a positive 1. We follow our mouth and put a plus, and our nose and put a minus. So does the last sign work? Negative times positive is a negative. That works. So this does factor. So all the factors are x minus 5 times x minus 3 times x plus 1. And that is it for this lesson. It's a pretty straightforward one. We're pretty short as far as the Algebra 2 lesson is concerned. Hope it's been helpful to you. We'll see you in the next one. Don't forget to like, comment, subscribe. We'll see you later. Bye-bye.